Good morning. Today we are going to see how to solve ordinary differential equation. Ordinary differential equation is a mathematical model for electric circuit problems. First, what is an ordinary differential equation? An equation which consists of ordinary derivatives is called ordinary differential equation. Where do we look for ordinary derivative? If there is only one independent variable in an expression and we are looking for the differentiation, then we go for ordinary differentiation. For example, in this case y equal to f of x, here x is the independent variable and y is the dependent variable, and when we look for differentiation, it is dy by dx. For example, when y function of x square and the derivative dy by dx is given as 2x. The derivative dy by dx is 2x. So before getting into the general format of ordinary differential equation, let us have an idea about what is an order and what is a degree. So in an ordinary differential equation, order is nothing but the highest derivative and power is nothing but degree is nothing but power of the highest derivative. So in the above equation, d cube y by dx cube plus 3 into d square y by dx square the whole square plus 5 into dy by dx plus y equal to f of x. In this equation, in this differential equation, here the highest derivative is what? Cube. So order is 3 and power of the highest derivative is 1. So the degree is 1. So now let us go for linear differential equation of nth order with constant coefficient. The general form of the linear differential equation of nth order is a naught d power n y by dx power n plus a1 d power n minus 1 y by dx power n minus 1 etc. plus a n y equal to x. Here a naught, a1 etc. a n are called the constants, and in order to represent it is nth order, this a naught should be not equal to 0. And this capital X is a function of small x. So let us go for solution. So the solution of this ordinary differential equation consists of two parts. The one is complementary function and the other one is particular integral. So first let us go how to find out complementary function. So here you are going to replace first d by dx as d and d squared y by dx squared as d squared. So this expression a naught d power n y x power n plus a1 d power n minus 1 dx power n etc. plus a n y equal to x implies a naught d power n plus a1 d power n minus 1 etc. plus a n equal of y equal to x. In order to get the complementary function, first let us consider the homogeneous equation. That is a naught d power n plus a1 d power n minus 1 etc. plus a n y of y equal to 0. Let us consider the right hand side equal to 0. This is your homogeneous equation. Next we are looking for the auxiliary equation. So the auxiliary equation is obtained by putting d is equal to m. So it is a naught m power n plus a1 m power n minus 1 etc. plus a n equal to 0. Hope you understand that this is a nth degree equation. So when you solve this equation, you are going to encounter n roots. So based on the nature of the roots, we are looking for the complementary function. Let the so assume the roots be m1, m2, etc. mn, and also the roots are real and distinct. Real and in this distance in the sense the first one root is 2 and the second one root is 3 and it is minus 1 like this, and this we call it as the roots are real and distinct. So in this case the complementary function is a e power m1x plus b e power m2x plus c e power m3x plus etc. And among the n roots, if two of the roots are equal, that is m1 equal to m2, and in this case the complementary function is ax plus b into e power mx plus c into e power m3x plus etc. So ax plus b, it is for two roots are equal. Suppose the three roots are equal, like the first root, second root, third root, all the sorry, all not all, the three among the n roots, three roots are equal, in this case the complementary function is obtained by writing ax square plus bx plus c. This x square, it is used to represent the roots are repeated. So ax square plus bx plus c into e power mx plus d e power m4x plus etc. And the next category is when the roots are complex. In the case of complex, like alpha plus or minus I beta, I hope you understand this is complex form. And the complementary function is e power alpha x into a cos beta x plus b sin beta x. Alpha the real part and beta the imaginary part plus c3 e power m3x plus etc. So with this idea, you can able to write the complementary function. The complement when the roots are real and distinct, this is the complementary function. Two of the roots are equal, we are writing ax plus b for repetition. When three of the roots are equal, we are writing ax square plus bx plus c into e power mx. This is this ax square plus bx plus c is for repetition. When the roots are complex, it is e power alpha x into a cos beta x plus b sin beta x is used to represent for repetition for complex form. Next, we are looking for the particular integral. This is the template for particular integral. Pi is equal to 1 by phi of d into x. This phi of d is nothing but the left hand side of the differential equation, and this capital X is nothing but the right hand side of the differential equation. And here the right hand side of the differential equation, there are three cases. The first one is exponential format, and the second one is trigonometric format, and the third one is algebraic expression or a polynomial expression. So for each case you have to go by different methods to get the particular integral. So the first, let us go with first type, that is x is capital X, the right hand side is e power ax. So in this case, the particular integral is obtained by replacing d is equal to a. And you should note that after replacing d is equal to a, you should note that the denominator should be 0. If denominator is 0 comes, so you cannot go by 1 by 0 format, since 1 by 0 is infinity. So to avoid this, what you are going to do now, first you are putting x in the numerator and differentiating the denominator with respect to d. By x by phi dash of d into x, and you replace d by a, and similarly it continues until then we are getting denominator not equal to 0. This is the way we are looking for particular integral for exponential function. And next is trigonometric function, that is sin ax or cos ax. So here the particular integral is obtained by replacing b square equal to minus a square. And here also when you proceed like this, the denominator shouldn't be 0. So pi equal to 1 by, here the substitution is only for d square, not for d. So if you have some d like 1 by d plus 2 d minus 2 like that, the linear term comes in order, but the substitution is for d square. So for trigonometric functions, what we have to do now, just you multiply the numerator and denominator by the conjugate. So by the way, you can get the square value in d square value in the denominator, and you should note that here the d in the numerator is nothing but the differentiation with respect to x. So this is it, particular integral equal to 1 by phi of minus a square, then sin ax or cos ax. If denominator is 0 now, put x in the numerator and differentiate the denominator. While differentiating, if you have some linear terms in the denominator, you should multiply the numerator and denominator by the conjugate, and you proceed as before. And a third type is a polynomial expression. In the case of polynomial expression, you have to just take this numerator into the denominator into the numerator in the form of whole power minus 1. Suppose your problem is of this kind, 1 by d square plus 5d plus 2. So here for this technique, and this x is your right hand side is x, this is a polynomial expression. In this case you have to take 2 outside, so it is 1 by 2 into 1 plus then remaining terms d square plus 5d by 2, and you have to take this d squared plus 5d by 2, 1 plus d squared plus 5d by 2 into the numerator, and you expand using the formula 1 plus x the whole power minus 1, or 1 plus x the whole power minus 2 and 1 minus x the whole power minus 1, 1 plus 1 minus x the whole power minus 2 format. Expand using binomial expression. And here also you should know that if you have some d in the numerator, and this d is nothing but the differentiation of the function with respect to x. So now let us see some examples. So for e power ax, this is the problem, d square plus 6t plus 5 of y equal to e power minus 5x. In this case, first we are looking for complementary function. So consider the homogeneous equation d square plus 6t plus 5 of y equal to 0. The auxiliary equation is obtained by putting d is equal to m, and it is m square plus 6m plus 5 equal to 0. And to get the roots, we can write 5 as 1 into 5. So for multiplication it is 5, and for addition it is 6. So you can go for the roots 1 and 5. So m plus 1 into m plus 5 equal to 0. This is the factor. Let the roots be minus 1 and minus 5. The roots are real and distinct, and in this case the complementary function is a e power minus x plus b e power minus 5x. And next we are looking for the particular integral, and this is the template 1 by the left hand side d squared plus 6t plus 5, and here you write the right hand side, it is e power minus 5x. And for exponential functions, the particular in order to get the particular integral, you have to replace d by a. What is a here? Minus 5. So this is minus 5 the whole square plus 6 into minus 5 plus 5 into e power minus 5x. And when you substitute, you are getting the denominator 0. So here you cannot quit this step 1 by 0 since it's infinity. So to avoid this, you are putting x in the numerator and you are differentiating the denominator with respect to x. So the differentiation of x, d squared is 2d plus 6. 2d plus 6 into e power minus 5x. So the particular integral is minus x by 4 into e power minus 5x. So by adding complementary function and particular integral, you can get the complete solution. Next we will see one problem on trigonometric function type 2. So here comes the problem, d squared plus 4 of y equal to sine 2x. So first now we are looking for the complementary function. So d squared plus 4 of y equal to 0, homogeneous function. Put d is equal to m. So you can get m squared equal to minus 4. The roots be m equal to plus or minus 2i. So this is alpha plus or minus I beta format. This is complex format, and here alpha is 0 and beta is 2. In the case of complex form, the complementary function is e power alpha x into a cos beta x plus b sin beta x. So e power 0x into a cos 2x plus b sin 2x. Since e power 0 is 1, the complementary function is what? A cos 2x plus b sin 2x. Now we are looking for particular integral, and here as per template you are writing it as 1 by d square plus 4 into sin 2x. For trigonometric functions, as we learnt earlier, the substitution is for d square. D squared equal to minus a square. Here a is what? 2. So d squared equal to minus 4. And when you substitute d squared equal to minus 4, it is 1 by minus 4 plus 4. So minus 4 plus 4 will become 0. So here we cannot quit this step. For whenever denominator 0 comes, you have to go by putting x in the numerator and differentiate the denominator. So when you differentiate the denominator, d square, the differentiation of d square is 2d and differentiation of 4 is 0. So it comes as x by 2d into sine 2x. And we know that for trigonometry functions, d squared is our substitution. So you multiply and divide by d. Since if there is any linear expression, you go for conjugate. Here it is simply d. So you multiply and divide by d in order to make the denominator d square. So x into d by 2d square into sine 2x. And now you replace d square by minus a square. It comes like this, minus 8, and d, the differentiation of d is what, sine is what, 2 cos 2x. So on simplification you can get particular integral as minus x by 4 cos 2x. So by adding complementary function and particular integral, the complete solution is obtained. And your third type is polynomial expression x power n. Before going to the polynomial third type, let us have some formula related with it. 1 plus x the whole power minus 1. This is nothing but a binomial expansion. 1 minus x plus x squared minus x cube plus etc. And next is 1 minus x the whole power minus 1. It is 1 plus x squared plus etc. And next 1 plus x the whole power minus 2. It is 1 minus 2x plus 3x squared minus 4x cubed plus etc. And next is 1 minus x the whole power minus 2. It is 1 plus 2x plus 3x squared plus 4x cubed plus etc. So this is the problem, d squared plus 2 of y equal to x squared. So first we are looking for the particular integral since we know complementary function part. So 1 by d squared plus 2 into x squared we are writing according to the template, and we are making the denominator in the form of 1 plus by taking 2 as outside. For 2 into 1 plus d squared by 2 into x squared. So it is 1 by 2 into 1 plus d squared by 2 whole power minus 1 into x squared. So we are here you replace d squared by 2 as x. So 1 plus x the whole power minus 1, it is 1 minus x plus x squared minus x cube plus etc. So when you expand 1 by 2 into 1 minus, here x is d squared by 2 plus d squared by 2 whole square plus etc. into x square. And we are looking for the derivative. D of x squared is 2x, and we are going to operate 1 into x squared is x squared and d squared by 2 of x squared. For that we need the differentiation of x squared. Differentiation of x squared as 2x, and the second derivative of x squared is 2 and the third derivative is 0. So here fourth derivative is 0. So it is 1 by 2 into x squared minus 1. So you add the complementary function and particular integral, it will give you the general complete solution. Hope you can understand this session. Thank you.